Hello viewers, welcome back to my channel Experience of Physics and for the topic meter bridge. Meter bridge, this bridge is an extension or modification of Wheatstone Bridge. So in our last videos, we have seen about Wheatstone Bridge, balanced Wheatstone Bridge as well as unbalanced Wheatstone Bridge. This meter bridge is the practical application of this Wheatstone Bridge. So accuracy wise, meter bridge is the best method for knowing the unknown resistance value. The Wheatstone bridge is normally used to find the value of one unknown resistance. Like a wire is given, its value is not available, right? You can use the Wheatstone bridge arrangement to find the value of that particular wire. Similarly, this meter bridge is also used to find the value of an unknown resistance or unknown wire's ohm value. So let me draw the diagram first. For Wheatstone bridge, this is a typical arrangement we will draw for the Wheatstone bridge. These are terminals A and B. This is terminal C and D. In between terminal C and D, we will have the galvanometer. This is one battery connected between A and B. Between C and D, galvanometer is connected, right? So 4 resistors we will use. 2 resistors are having fixed value. This is fixed. Let me have, this is also a fixed. This may be unknown value. And this is not fixed, variable value. This resistor is variable, right? We can vary the value of these resistors at any value. Right? Usually a resistance box is kept here. Its value is different. Combinations of values can be made here, right? Between B and D, right? So anywhere you can put the resistors here. Right? Say this is P and this is Q and this is R and this is S, right? This condition also we have seen already. P by Q is equal to R by S. If this ratio is met, the current through the galvanometer will be 0. To have the current through the galvanometer, I must have this ratio. P by Q must be equal to R by S. That means to have this ratio satisfied, we can vary the value of this S because it is variable resistance. Any value you can vary. Right? By adjusting the value of this S, you are making this P by Q is equal to R by S. This is what we have studied in the under the heading Wheatstone Bridge. Right. This condition is known as null position of the galvanometer or the condition of balancing. Condition of balancing. Or null position of the galvanometer. Null position. So the galvanometer won't show any deflection, 0 value. So Ig is equal to 0. Galvanometer is the miniature form of 1 ammeter. Right. So meter bridge, the same arrangement, I will draw this way. This is the simplest diagram of a meter bridge. Terminal A, terminal B. This is C and this may be D. Between C and D, the galvanometer is connected. Yes, this is simplest form. A and C, one value. C and B, another value of resistance. A and D, the green wire represents 1 meter length wire. 1 meter length. The green wire represents 1 meter length. That is 100 centimeter usually. In terms of centimeter, we will solve all the problems. This is the battery V voltage. This galvanometer, one end of the galvanometer is fixed here. The another end is made as to move on the slide wire. So this point is known as jockey. This point is known as a jockey. The jockey point can be moved on the green wire at anywhere from here to here, from 0 centimeter to 100 centimeter. So the D point D cannot be at a fixed value permanently. The D value is adjusted from here to there. From 0 centimeter to 100 centimeter, any place the D can be put, right? So this is the adjustable one. This value is a standard value. Yes, this is unknown value. So R is the unknown value. S is the standard value, that is fixed value. R is the unknown value, S is the fixed value, right? We will have, right, here the green wire, we are having the green wire, this length, let me write it as L1 meter, right? 100 centimeter or L1 centimeter. This length is L1 centimeter. Then this will be naturally 100 minus L1. Yes. Using these values, we will solve all the problems and we will achieve this condition. R divided by L1, instead of this P by Q, R divided by L1 is equal to S divided by 100 minus L1. Yes, that's all. Over. R divided by L1 must be equal to S divided by 100 minus L1 over. This is how meter bridge is constructed. Just it is the modification of Wheatstone Bridge, right? So this is how meter bridge is constructed. The advantage of having meter bridge is this jockey point. The jockey point is the knife-edged contact, such a sharp contact, right? To improve the accuracy of this working of this meter bridge, the contact must be a sharp one, right? Jockey point. So from this place to this point, we can vary the jockey point wherever the position when the null position is obtained. So this is varied here by seeing the galvanometer when it is becoming 0, right? So this is the easiest, simplest form of this meter bridge, right? Let me show the practical setup of 1 meter bridge. So this is a practical setup, experimental setup, right? These are copper strips. So this is a conducting part, right? R is unknown value. We are going to find the value of this R value only. S is the standard value, known value. S is known value. And this white color wire is our 1 meter length slide wire. This is L1 or L. And this is 100 minus L1 in terms of centimeters, right? Meter bridge, but we will take the centimeter. This is the battery, right? If we connect the battery, this will send one current here. The current path will be completed this way, right? This is how the current path is completed. Through R, then through S. So this is another path. Through the galvanometer, another path, the current can come, right? On the slide wire also, the current is taking its path. The slide wire also. By adjusting the galvanometer position, we will find the null position of the galvanometer. So accordingly, the L1 will vary. Accordingly, the L1 will vary, right? So finally, we will write this R by L1 is equal to, as I said, S divided by 100 minus L1. So you know interchangeably you can find R by S also. This is also possible. L1 divided by, both are right. Mathematically both are right. So you can bring S here and L1 to the top of the right hand side. R by S divided by L1 by 100 by L1. So both ratio are right. So this is the construction and working principle of 1 meter bridge, right? We will try to solve few exercises. The first one is, in the shown setup of meter bridge, there is no deflection in the galvanometer, right? That means it is balanced. This is 60 ohms, so standard value, known value. This is unknown value, and this is 30 centimeter. The value of the unknown resistance is what? This value is to be found. What is this value, right? So 30 centimeter means 1 meter. So 100 minus 30, 70 centimeter will be this length. So at this position, the galvanometer is showing 0 deflection. So easily we can write 60 by 30 divided by R by 70. 0 removed, 6 by 3 is equal to 2. So 2 is equal to R by 70. R is equal to 2 into 70, 140 ohms. R is equal to 140 ohms. Option 3. Yes, over. Then this problem. Two resistances, 100 ohms and X ohms, are connected in left and right gaps. This is one gap. This is one gap. This is another gap. Left gap, right gap. L1 and L2 are balancing lengths. L1 and L2 are balancing lengths from left and right respectively. L1 left length, L2 right length. When one more 100 ohm is connected, in parallel with the unknown resistance X. One more 100 ohm is connected in parallel with the unknown X, then L1 by L2 becomes 2. Then the value of X is what? X is what? Previously, 100 by L1 is equal to X by L2. 0 deflection. Balanced. Now, they are connecting another 100 ohms in parallel with X. What will happen to the value? What is the value of this X? So, this is what the given condition. E internal resistance, E its EMF, R is the internal resistance. We need not worry about these values, right? We have to find the ratio only, right? So in the case 1, 2 cases. First case, without having the 100 ohms. This is case 1. 100 divided by L1 is equal to X divided by L2. Then case 2, we are connecting 100 ohms here in parallel to X ohms. 100 by L1 is equal to X into 100 parallel value. X into 100 divided by X plus 100. R1, R2 divided by R1 plus R2 divided by L2. So we can write 100 divided by, because the L1 by L2 becomes 2. This is one value they are giving. So I am going to find L1 by L2. What L1 by L2 is coming? 100 divided by cross multiplying 100x divided by 100 plus x is equal to L1 is going to the top numerator and this is L2. L1 by L2 is 2. Here 100 can be removed. The 100 plus x will go as numerator. 100 plus x divided by x is equal to 2. right? Then 100 plus x is equal to 2x. 100 plus x is equal to 2x. X, if you take it to right side, 100 is equal to 2x minus x, that is x. X value is 100 ohms. That is the answer, right? X value is 100 ohms. Option 3. Option 3 is the right answer. Resistances in the two gaps, left gap, right gap, of a meter bridge are 10 ohms and 30 ohms respectively. If the resistances are interchanged, then the balance point is shifted by how much? Let us draw the diagram first. This is our meter bridge, galvanometer. This may be L1 and this should be 100 minus L1. Resistances in the two gaps of a meter bridge are 10 ohms and 30 ohms respectively. So this is 10 ohms and this is 30 ohms. This is case 1. In case 2, if the resistances are interchanged, we are interchange the resistances. So 30 ohms comes here, then this is 10 ohms. L1 100 minus L1, right? This is galvanometer jockey point. Okay. 10 by L1, we will write the ratio. 10 by L1 is equal to 30 divided by 100 minus L1. So only one variable, L1 is the only variable. We can find it easily. 0 I am removing. 100 minus L1 divided by, 100 minus L1 is equal to 3L1. Easily we can write this way. Hundred minus L1 is equal to 3L1. So 100 is equal to 4L1. So L1 is equal to 100 by 4, 25 centimeter. So this is for case 1. So L1 is 25 centimeter and this will be 75, 100 minus L1. This is how the jockey point is moving. And here 30 by L1 must be equal to 10 divided by 100 minus L1. As usual, I am removing 3. So 300 minus 3L1 is equal to L1. So 300 is equal to 4L1. The L1 is equal to 300 divided by 4, 75 centimeter. Then this case, this is 75 centimeter, it must be 25. In the first case, L1 is 25. In the second case, L1 is 75. So the jockey point has moved by 50 centimeter. If the resistance are interchanged, the balance point is shifted by how much value it is shifted. Originally it was at 25, then it is coming to 75. So the shifting is only 50 centimeter. 50 centimeter is the answer. 75 minus 25, right? 50 centimeter is the answer. From the original position, it is increasing by 50 centimeter. New position is 75 centimeter. Two wires of same material and same length. Two wires, same material and same length are connected to the two gaps of a meter bridge. The balancing length measured from left is 25 centimeter. Measured from left is 25 centimeter. The radius ratio of the wires are in the question. In the left gap to the right gap is what? So we know R is equal to rho L by A. So from here, from A we will find the ratio, right? So two wires. First let me draw the diagram first. Two wires of same material and same length. left gaps and right gaps. The balancing length measured from left is 25 centimeter. This is 25 centimeter. So this is R1 and this is R2. And this must be 75 centimeter. 100 minus 25. This is given. So ratio of the ohmic value is not available, okay, not asked. Its radius of the wires are asked. R1 and R2. Their ohmic value must be converted into area and area value must be converted into radius. So that is the idea. R1 divided by 25, as usual we will write R1 divided by 25 is equal to R2 divided by 75, or R1 by R2 is equal to 25 divided by 75 is equal to 1 by 3. So R1 by R2 is equal to 1 by 3. Then R is equal to rho L by A, same wire, same material and same length. So rho is constant, L is also constant. R is proportional to 1 by A only. R is proportional to 1 by A. So R1 by R2 is equal to, R is proportional to 1 by A, R1 by R2 is equal to A2 by A1. Let me write it here. R1 by R2 is equal to A2 by A1. A is equal to pi R square by 4. Pi R1 square by 4 divided by pi R2 square by 4. So pi by 4 and pi by 4 are removed. So this will be R1 square by R2 square. So R1 by R2 is equal to R1 by R2 square. This is resistance and this is radius. R1 by R2 is equal to 1 by 3. So R1 by R2 square is equal to, instead of this R1 by R2, I am writing 1 by 3. So if you take the square root, R1 by R2 is equal to 1 divided by root 3. So this is A2 by A1. I am sorry, here there is a mistake. This is R2. This is R1. R2 by R1. R2 by R1. R2 by R1. R2 by R1 square is equal to 1 by 3. The question is the ratio radius of the wire in the left gap to that of right. So R1 by R2 square is asked. R1 by R2 square means it is 3 by 1. So taking the square root, it is root 3 by 1 or 1.73 by 1. This is the answer. Option A. R1 by R2 is equal to root 3 by 1. Root 3 value is 1.73. Right. Next problem. A meter bridge is set up as shown to determine an unknown resistance using a standard 10 ohm resistor. X value is found using this bridge using a 10 ohm resistor. The galvanometer shows null point when tapping key is at 52 centimeter. 52 centimeter tapping key. This is galvanometer. The end correction are 1 centimeter and 2 centimeter respectively for the ends A and B. The end correction are, this is the new line we are seeing. The end correction are 1 centimeter and 2 centimeter respectively for the two ends A and B. This side 1 centimeter and for B end correction it is given as 2 centimeter. The determined value of X is what? What is X? End correction, what is end correction? We will see. This is 52 centimeters. So then this must be 48 centimeter, right? 100 centimeter total length, 1 meter. So end correction. This is one wire, slide wire. So the slide wire, it is not exactly 1 meter or 100 centimeter. Right? When it is tightened at this end, some more length, 1 centimeter extra length is also used here. So it is tightened at this point A using the screws. Similarly, at point B, some more length, 2 centimeter, 2 extra centimeter, extra wire, 2 centimeter is also, it is available, right? Between A and B, exactly it is 100 centimeter, but the total length of the wire the user used is 103 centimeter, not 100 centimeter. This side 1 centimeter extra length, this side extra length is 2 centimeter. So you know current passes in the extra wire also. The current cannot pass the exactly at the 100 centimeter. It will follow the entire length of the wire. So the current is passing through the extra length. So current is passing through the 103. So technically 103 centimeter is available here, not 100 centimeter. Meter bridge, the concept of meter bridge is having only 100 centimeter, but the end correction is also given in this problem. So the extra wire is also available here. It must be taken into account. So this side it is not 52 centimeter, it is 53 centimeter, 52 plus 1. This side it is 48 plus, yes, instead of 52 I must have 53, instead of 48 I must have 50 centimeter. So this is how end correction problem must be solved. Then x divided by 53 is C. Then as usual I will write x divided by 53, 52 plus 1 is equal to 10 divided by, it is 50. 0 removed, 5x cross multiplied, it is 53. So x is equal to 53 divided by 5 into 2 both sides. So this is 106 divided by 10. I am multiplying the numerator and the denominator by 2. So this will be 10.6. The answer is 10.6 ohms. Option 2. Option 2 is correct answer. Right. Next problem, a resistance of 2 ohms is connected across one gap of a meter bridge. The length of the wire is 100 centimeter. And an unknown resistance is greater than 2 ohms is connected across the other gap. Unknown resistance value, but it is more than the 2 ohms value. The standard value is 2 ohms. Yes, let me draw the diagram. This is 2 ohms. This is unknown value, but its value is more than 2 ohms. This is the meaning of that line. When these two resistances are interchanged, the balance point shifts by 20 centimeter. Neglecting any corrections, no end corrections. The unknown resistance is what? R is equal to what? This is case 1. Case 2, they are interchanged. This is R and this is 2. R value is greater than 2. This is L, 100 minus L. So this is the balance point shifts by 20 centimeter. That means originally this is L. Now the balance point is shifting by 20 centimeter. Since R value is greater than 2 ohms, R is more than this 2 ohms. So it may be 3 or 4 or 5. So the shifting should be happen on the right hand side. L plus 20. Isn't it? For this case, for this meaning only they are giving this hint, it is greater than 2, or otherwise you can reduce, you can write L minus 20, right? So shifting means the shifting is done on the right hand side, L plus 20, L is becoming L plus 20. So this will be 100 minus L plus 20, the rest value. From 100 we are reducing this value, right? See, we will write the ratio. This is 2 by L, case 1, 2 by L is equal to R divided by 100 minus L. Or we can write 2 by R is equal to L divided by 100 minus L. This is for case 1. And for case 2, R divided by L plus 20 is equal to this 2 divided by 100 minus L plus 20. 100 minus 20 is 80. So this is 2 divided by 80 minus L. This side it is R divided by L plus 20. Here it is 2 by R. Here also I want to have 2 by R. 2 by R. 2 by R is equal to 80 by L divided by L plus 20. 2 by R is equal to 80 by cross multiply 80 by L divided by L plus 20. So this is 2 by R and this is also 2 by R. 2 by R. We can equate these two equations. L divided by 100 minus L is equal to 80 by L, 80 minus L by L plus 20. So this is cross multiplied. L square plus 20L is equal to 100 minus L into 80 minus L. So this is 8000 minus 100L minus 80L plus L square. So this is L square plus 20L. 80 into 100, then 100L, 80L plus L square. So L square, both sides it is removed. This is minus 180L. 8000 minus 180L is equal to this side 20L. This can be taken here. 180 plus 20, it is 200L is equal to 8000. So two zeros we are removing. L is equal to 80 by 2 is equal to 40 centimeter. But the question is, unknown value, R value is what? L is equal to 40 centimeter, but any one of the equation we can put here. This equation we will put. L is equal to 40 centimeter. So R value it is asked. This equation let me write here. 2 by R is equal to, L is equal to 40. We have seen now. L is equal to 40. So 100 minus 40 is 60. So it is R is equal to 4R is equal to 2 into 6, 12. R is equal to 12 by 4 is equal to 3 ohms. I am getting 3 ohms. Option A. Option A is right answer. 3, 4, 5, 6. 3 is right. Here in a meter bridge experiment, when the resistances in the gaps are interchanged, the balance point did not shift at all. Right? This is one resistance, this is another resistance, this is a galvanometer, L1 and L2. The balance point did not shift at all. We are interchanging these two resistors. But L1 and L2 remain same. That means both the values are same. Then the ratio of resistances in the gap is very large, very small, equal to unity and 0. Equal to unity. So this R divided by L1 is equal to, this is S divided by L2. Since R is equal to S, L1 by L2 is equal to unity. Same value. Easy problem. When a metal conductor connected to left gap of a meter bridge is heated, the balancing point is right. So this is heated. This R is heated. So delta R will increase. We have studied temperature dependence on resistance. If R is heated, delta R will be increased. The R value will become more. Then this jockey point will be shifted to the right. To maintain the ratio, shifts towards right. Option A is correct. This problem, this is modified meter bridge. The diagram shows a modified meter bridge which is used for measuring two unknown resistance at the same time. Simultaneously, two unknown resistance values are found, R1 and R2. R is the standard value, let us assume. When the first galvanometer, G1, first galvanometer alone is used, in that case, G2 is not available. Only G1 is available. We can assume G2 is not here. When the first galvanometer alone is used, the balance point is found at C, right? So the D can also be forget. Let us forget point D also. Now the first galvanometer is removed, then they are removing the first galvanometer and the balance point is found at next. G1 is removed and G2 is used and D is now found as the new balancing point. Using the details given in the diagram, find the value of R1 and R2. What are the details? AB is equal to L. The length of the wire is L. AC is equal to L by 4, 1/4 L. Then CB must be 3/4 L naturally. Then AD is equal to 2/3 of L. AD is 2/3 of L. This is 2/3 of L. Then it must be 1/3 of L, right? First they are using the first galvanometer, so they didn't bother about G2, or we can assume G2 is not connected. Then they connect G2, then they removed G1. So two cases we have to analyze. First I am having only G1. Take only G1. G2 is removed. So we can forget G2. So this is R. If we forget G2, this R1 and R2 are coming in series. That's all. So R divided by AC is equal to R1 plus R2 by CB over R divided by AC is equal to, now this is R1 plus R2 series. CB. Then second case G1 is removed. So R and R1 are coming in series. Second case only G2. G1 is removed. R plus R1 divided by AD. So R2 by dB. Yes, over. Then we have to write their lengths. The details are given. What is AC, what is CB, what is AD, what is dB. AC is equal to L by 4. R divided by L by 4 is equal to R1 plus R2 divided by, if it is L by 4, then this is 3L by 4. 3 times of L by 4. This is L by 4. So the remaining is 3 times of L by 4. So L by 4 we can remove. 3 can be taken here. 3R is equal to R1 plus R2. So they are wanting to find what is R1 and what is R2. Actually, this is a question. Find the value of R1 and R2. That is the question. R1 is some value in terms of R given. R2 is some value in terms of R. R1 is another value. Option D is both A and B. A is also available. B is also available. We have to check all the options. Right. So in case 1, we are getting 3R is equal to R1 plus R2. Right. Next we will come here. AD is equal to 2/3 of L, 2L by 3. That is 2/3 of L. So this is 1/3 of L. R plus R1 is equal to 2/3 of L. AD is equal to R2 divided by 1/3 of L. So L by 3 we can remove. 2R2 is equal to cross multiplying R plus R1. So the options are R1 in terms of R, R2 in terms of R, right? If we find R1, then the right hand side R can be coming, right? R1, R2 in terms of R only we have to make. So this is 2R2. From here I am writing R is equal to 2R2 minus R1. Because both are written in terms of R only. This is 3R, this is single R. Equation 1 and equation 2. One of the values first we will remove. This is R1 plus R2, this is 2R2 minus R1, right? Minus R1 is available. Let us remove R1 first. So this is using equation 1, I am writing 3R is equal to R1 plus R2. Then R is equal to minus R1, first I am writing here, plus 2R2. So this is 4R is equal to R1 and R2, R1 and R1 are cancelled, this is 3R2. From here R2 is equal to 4 by 3R. R2 in terms of R we found. R2 is equal to 4 by 3R. R2 is equal to S. R2 is equal to 4 by 3R. Option B is right here, but look at option D, both A and B. So we have to check whether A is also a possible answer. If A is also possible, then we must choose D as the answer, right? We should not tick option A or option B independently. We must go for option D. Option D will give you the correct option. So option A we have to check. For that we have to find what is R1. Now R2 is found. Let me put it in 1. This R2 is taken to this equation. 3R is equal to R1 plus R2. Instead of R2 I am writing 4 by 3R. So 3 minus 4 by 3R. 3R minus 4 by 3R is equal to R1. So this is 9 minus 4. 9 minus 4. This is 5 by 3R is equal to R1. R1 is equal to 5 by 3R. 3 into 3, 9. 9 minus 4, yes, 5 by 3. 5 by 3R. R1 is equal to 5 by 3. Yes, option A is also right. Option A is also right. R1 is equal to 5 by 3R. Correct. R2 is equal to 4 by 3R. Correct. This is not correct. But option D must be the right answer. Both A and B. So we have to choose option D. Next problem. The resistances in the two arms of a meter bridge are 5 ohms and R ohms respectively, and balancing is at length L1 as shown in figure. If it is L1, this is 100 minus L1, right? When the resistance R is shunted in parallel with an equivalent resistance R1 is shunted with an equivalent resistance. Another resistance R is connected here. The new balance point is at 1.6 L1. Then the resistance R is what? Yes. So in condition 1, there is no equivalent value. This is the original case. Case 1. Case 1. 5 divided by L1 is equal to R divided by 100 minus L1. Then case 2, 5 divided by, here now we are going to connect one more resistance here. So the equivalent value will be R by 2, isn't it? Two equal values are coming in parallel, so the net value is R by 2. So 5 divided by, this is now becoming 1.6 L1. Yes. Look at the statement. When the resistance R is shunted in parallel with an equivalent resistance, the new balance point is 1.6 L1. So now for second case, this is 1.6 L1. Then this will be 100 minus 1.6 L1. The rest value, the remaining value is 100 minus 1.6 L1. So case 2, 5 divided by 1.6 L1. 5 divided by 1.6 L1. Here it is changed to R by 2. Two resistances, equal values, they are in parallel. 100 minus 1.6 L1. This can be written as 5 divided by 1.6 L1 or 2 I am taking to the denominator 2 into 100, 200 minus 2 into 1.6, 3.2 L1. This is 5 by L1, this is R by 100 minus L1. This is 5 by 1.6 L1, this is R. So 5 by R. If we find 5 by R, then we can equate both the equations. 5 by R is equal to L1 divided by 100 minus L1. 5 divided by R is equal to, similarly 5 by R is equal to 1.6 L1 divided by 200 minus 3.L1. Equation number 1, equation number 2. These two can be equated. L1 by 100 minus L1. L1 divided by 100 minus L1 from equation 1. Then from equation 2, 1.6 divided by 200 minus 3.2. 1.6 L1 minus 200 by 200 minus 3.2 L1. The L1 we can remove. 200 minus 3.2 L1 cross multiplied. 200 minus 3.2 L1 is equal to 1.6 into 100 is 160 minus 1.6 L1. 200 minus 160 is equal to 3.2 L1 minus 1.6 L1. This is 40. This is 1.6 L1. So L1 is equal to 40 divided by 1.6. So this can be written as 400 divided by 16. 4 fours are 16. Then this is 1,400. 100 by 4 is 25. L1 is equal to 25 centimeter. L1 is now found. The question is not L1. Then the resistance R is what? R is connected in parallel with another R. Yes. Now L1 is found. It is 25 centimeter. So here any one of the equation we can write. 5 by R is equal to L1 by 100 minus L1. So 5 by R is equal to L1. Now it is obtained. L1 is 25 centimeter. L1 is 25. Then 100 minus 25, it is 75. So this is 25, this is 75. So 3 times of 25 is 75. So 3 into 5, R is equal to 15 ohms. 25, 75, 3 into 5, R value. Option C. 15 ohm is the answer. Next problem, the resistance in the left and right gaps of a balanced meter bridge are R1 and R2. R1 and R2. Okay. The balanced point is 50 centimeter. 50 centimeters. So it must also be 50 centimeter. If a resistance of 24 ohm is connected in parallel to R2, next case. This is R2. Now 24 ohm is connected here. If a resistance of 24 ohm is connected in parallel to R2, the balance point is at 70 centimeter. Then it must be 30 centimeter. The value of R1 or R2. The value of R1 or R2. So they have given the hint. Since it is 50 and 50, R1 must be equal to R2, isn't it? From the case 1, it is understood that R1 and R2 are same. 50 centimeter and 52 centimeter, 50 centimeter, right? So let us work second case and we will find whether R1 and R2 values are either 12 or 8 or 16 or 32. R1 by 70. So this is parallel. 24 R2 divided by 24 plus R2 divided by 30. So this 0 can be removed. So 3 R1 by 7, 3 is taken here, is equal to 24 R2 divided by 24 plus R2. Since R1 is equal to R2, we can remove R1 and R2 are same. R1 is equal to R2. So I am removing this R1 and R2. So this is 3 by 7. 3 by 7 left hand side is equal to 24 R2 divided by 24 plus R2. So only one variable it is available, R2. We can find easily the value of R2. So this is 3. This is 8. 8 times 8 into 3, 24. So 7 into 8, 56 R2 is equal to 24 plus R2. Then R2 so this R2 I have removed. Yes, I shouldn't have this R2 here. 3 by 7 is equal to 24 divided by 24 plus R2. I shouldn't have R2 here. So this is 7 into 8, 56 only. So R2 is 56 minus 24. That is 32. 32 is the answer. R1 or R2 are 32. Both are 32. Next problem. In the meter bridge shown, the resistance X has negative temperature coefficient. negative temperature coefficient. Neglecting the variation in other resistors, when current is passed for some time, the balance point in the circuit should shift this side or that side. So this is one condition. After some time, the resistance X is heated. The resistance X has negative temperature coefficient. That means it may be a thermistor or a semiconductor. So when temperature is increased on it, negative temperature coefficient, the resistance value is decreased. When temperature is increased, X value is decreased. Negative temperature coefficient, right? It is not a metal. X is not a metal. After some time, the balance point in the circuit should shift towards which side? So this is from case 1, now X value is decreased. So the galvanometer positions must come this side. This is a new position, right? So the jockey point should towards B. That is the answer. The balance point in the circuit should shift towards which side? Option A, option B, option C is first A, then B. It will remain at C. So it is shifting towards B. Option B is correct. Next problem, in a meter bridge experiment, when the resistance wire is connected in the left gap, the balancing point is found at 30 centimeter. And when the first wire is replaced by another wire, the balancing point is found at 60th centimeter. Find the balance point when the two wires are connected in parallel in the left gap. 3 cases they are given. They have given 3 cases. Case 1, "30 centimeter. Case 2, "60th centimeter. This is first wire. Say this is R1 and this is R value. Now second wire R2, this is not at all changed. R value, so only they are changing this value only. Connected in the left gap. The left gap wire is only changed. So first wire 30 centimeter. R is as such. It is kept as such. R2, now it is 60 centimeter. Then find the balance point, this point, when the two wires are connected in parallel in the left gap. Right? Two wires, R1 and R2. R1 and R2 and R. This balance point is now asked. It is 30, this is 60, this is how much? That is the question. So as usual, we will write this is 70 centimeter and this must be 40 centimeter. R1 by 30 equal to R by 70. So this 0, 3 by 7 R. R1 is equal to 3 by 7 R. Here R2 by 60 is equal to R by 40. Then R2 is equal to 6 by 4R. Or we can write 3 by 2R. R2 is equal to 3 by 2R. R1 is 3 by 7R, R2 is 3 by 2R. Here R1, R2 divided by R1 plus R2 This is this resistance divided by this is L, and this must be 100 minus L. The L is in question. Balance point when the two wires are connected in parallel. Find the balance point. So this is L is equal to R divided by 100 minus L. So this equation let me write in the next page. R1 R2 divided by R1 plus R2 divided by L is equal to R divided by 100 minus L. R1 R2 by R1 plus R2 by L is equal to R divided by 100 minus L. Then R1 R2 values are found separately in the previous two cases. R1 3 by 7R, R2 3 by 2R. 3 by 7R and 3 by 2R. 3 by 7R into 3 by 2R divided by 3 by 7R plus 3 by 2R. Divided by this L is equal to R by 100 minus L. So this can be simplified. 3 into 3, 9, 9 by 14 R square, 9 by 14 R square. Divided by, this is 14, we can take LCM, 2 into 3, 6R plus 7 into 3, 21R divided by L is equal to R divided by 100 minus L. 14 and 14 can be removed. So this is 9R square divided by 27R divided by L is equal to R divided by 100 minus L. This L can be taken to the right hand side. 9R square divided by 27R is equal to L into R divided by 100 minus L. One R I can remove, this R can also be removed. So 9 divided by 27, 9 divided by 27 is equal to L divided by 100 minus L. This is 3. 3 into 9, 27. So 3L is equal to 100 minus L. 4L is equal to 100. L is equal to 100 minus 4 is equal to 25 centimeter. So the balancing point is 25 centimeter. This is 30 centimeter when R1 alone is available. R2 alone is available 60. Then these two are connected in parallel. This is 25 centimeter. That is the answer. 15, 20, 25 centimeter, option C, right? Right guys, this is the end of our lecture. Try and solve many problems, right? Again and again you solve any number of problems, again and you, meter bridge is the easiest topic. Only one condition we are using. So that ratio from Wheatstone Bridge, what we have studied, that ratio we are using it. So such an easy topic, you can score marks if any question is coming in this area, right? So thank you for watching this video and good luck guys.